Hello all. In this learning educational dialogue 2 of kinematics of machine, we would be discussing the basics of kinematics and the scope. Here we'll discuss first with the mechanism. According to German scientist Franz Rühlix, a mechanism is defined as an assemblage of resistant bodies connected by movable joints to form closed kinematic chain with one link fixed and having the purpose of transforming motion. So if a kinematic chain is having one fixed link and there is relative motion between the others, then it may be called as a mechanism. The purpose of a mechanism is transforming a motion to convert one input motion into a desired output motion. So mechanisms we had discussed in the first learning educational dialogue 1 that slider crank mechanism is a kinematic mechanism in which translatory motion is converted into rotary motion of the crank. A simplified diagram, a kinematic diagram is shown here. This 3 represents a crank, and this translatory motion of this link 1 is converted into rotary motion of link 3. Now this is one kind of mechanism, but there are several types of mechanisms available. They may be broadly classified under 3 categories: planar mechanism, spherical mechanisms, and spatial mechanisms. A planar mechanism has all the components constrained to move in a single plane or parallel to a single plane. Then it is called as a planar mechanism. Best example is a pantograph, in which you can see that all the links are moving in a single plane. Pantograph mechanism is used in drafting purposes, where this pencil is used to draft on a second sheet. So it may be used to enlarge or reduce the scale of a drawing. Now the important thing is all the elements, all the links are moving in a single plane. So hence it is called as a planar mechanism. Spherical mechanisms are constructed such that the components are made to move in concentric spherical shells around a fixed point, and therefore they are called as spherical mechanisms. Example is a gimbal mechanism, which is used in gyroscope of any airplane or ship. Now you can see all the components are made to move, are constrained to move in spherical shells about a fixed point. So this fixed point is about which all the components are moving. Hence it is classified as spherical mechanism. The third category is spatial mechanism, in which the body or the components are allowed to move in a 3D space. A best example is a Stewart's mechanism, in which the components or the actuators, as seen over here, electrical cylinders, allow this top plate to move in 3-dimensional space. This top plate can be arranged in 3-dimensional space as per the requirement. On this plate, a simulator cabin is mounted, while this forms the rigid base which is fixed. So the spatial mechanisms have components which move in space, 3-dimensional space, hence they are classified as spatial mechanisms. For basic kinematics, we will be just limiting ourselves, focusing on planar mechanisms to simplify the learning curve. So this is what the scope of our dialogue would be in the further coming videos. A kinematic link. So kinematic link is the basic unit of any mechanism. It is a resistant body which moves relative to another resistant body. Now what is a resistant body is which does not undergo deformation while transmitting the force. This is the the definition for study of basic of kinematics. Okay, but there are different types of kinematic links which are available in practice. they can be broadly classified based on the material properties. There are three types: rigid link, flexible, and fluid. Based on the number of points of relative motion, they can be classified as binary link, ternary link, quaternary link. Now we'll discuss the based on the material properties, the link, a kinematic link can be classified as rigid link that do not undergo any appreciable deformation or change in shape while transmitting motion. This is used. These type of links are normally used in most mechanical presses and all the engines. Example is a connecting rod over here as shown in the figure, which do not undergo deformation while transmitting motion. The second type of kinematic link is a flexible link, which undergo partial deformation while transmitting motion, but this deformation does not hinder the transmission of motion. Example, belt or chain drives. So over here there is a belt drive that can be seen. This belt is flexible. It undergoes deformation while transmitting motion, but it does not hinder the effectiveness of the transmission of motion from this belt to this another second pulley. Okay, so between the pulley the motion transmission takes place without any hindrance. So this belt drive can be classified under flexible link. The third type is a fluid link, in which gas or liquid is used to transmit motion by means of pressure. The example is pneumatic punching presses, hydraulic jacks, hydraulic brakes. Here the hydraulic brake has been demonstrated over here. You can see that this pressure cylinder is used transmitting fluid pressure to this caliper assembly. This caliper assembly is connected to this piston cylinder through a fluid link. So it forms a link between the piston and the piston cylinder and the second piston cylinder arrangement or caliper arrangement. So this can be taken as a fluid link. For basic of kinematics, we limit ourselves to only considering rigid links which are having negligible amount of deformation while undergoing motion transformation. This is done to simplify the learning curve. Now, if a link is assumed to be rigid, then they can be classified under three types. First is a binary link, in which can be connected to two other links because they have 2 points of connection. Second is a ternary link, at which three links can be connected to it at 3 points. And in a quaternary link, which can be connected at 4 points. So 4 joints, a quaternary link can have 4 joints, ternary can have 3, and binary can have 2. So this is as far as the links goes. In the further coming chapters, we will be going through the terminologies for a kinematic mechanism. Thank you.